Hi, this is Math 2510, and this video is over chapter 1.1 in calculus, and this is the second part of this section. We left off with talking about increasing and decreasing functions, so that's where we're going to begin. A function is increasing if as x moves to the right, the graph moves up, meaning that if you have two values of x, x1 and x2, where x1 is less than x2, and we look at those function values, and the function evaluated at x1 is lower than the function evaluated at x2. Then you have a graph that's increasing. Now, on the other hand, if x1 is less than x2, and the function values for f of x1 is higher than the function value for f of x2, then the graph is decreasing. And so that's the definition of increasing and decreasing. Easiest way to remember is as x goes to the right, your graph moves up, it's increasing. If your graph moves down, like a downhill graph, then it's decreasing. And constant means that if you have x1 and x2, and the function of x1 is equal to the function at x2, then the graph is staying the same value, it's constant. All right. Next is composite functions. It's really ways of writing, shorthand almost ways of writing how you add, subtract, multiply, divide functions, or how you can substitute one function into another function. Right, so if you see f plus g of x, this is just f of x plus g of x. If you see f minus g of x, this is f of x minus g of x. If you see f times g of x, this is f of x times g of x. So you may have to FOIL or distribute. F divided by g of x, this is f of x divided by g of x. And we have to take into account that g of x cannot equal 0. That comes in when we're looking at the domain. And then the composite of f and g, this is g of x going into f of x. Okay, so one thing important with these really is just how we can separate functions out in their terms for one, or how we can do the substitute method as another example. But the important thing is also looking at the domain. So if you have x and it goes into the function g, and that then goes into the function f, that is, this is f composite with g. We look at it as the domain of g, they go in, and they are then a part of, when you take the function, you get the range of g. That range of g and the domain of f kind of create an overlap. And then when you take the function of f, you're getting out the range of f composite with g. Right. Main thing to remember with the domain is what you're looking at is that overlap or that intersection of it. All right, so let's take f of x being equal to 2x, g of x being equal to x plus 8. Both of these are linear functions. So the domain is negative infinity to infinity. So if we do f plus g of x, 2x plus x plus 8, and we just simplify it down, 3x plus 8. Your domain with the composition, there's no restrictions, it's just linear itself, so your domain doesn't change. It's still all real numbers, negative infinity to infinity. If you do f minus g of x, then you do 2x minus x plus 8. And you do the subtraction, you get x minus 8. Again, domain is all real numbers. If we do f times g of x, 2x times x plus 8, distribute 2x squared plus 16x. This is just a quadratic again, no restrictions, all real numbers. Basically, when you're looking at domains, you just have to look at restrictions. Restrictions for your either function, restrictions for your composition function. F over g, you have 2x over x plus 8. And there's really no simplifying you can do there, but we have to take into account that x cannot equal negative 8. Otherwise, you're dividing by 0. So your domain has to restrict negative 8. Right? And then the last one, g going into f of x, be 2 times x plus 8. When we distribute that, you get 2x plus 16. This is just linear, again, over numbers. So, a lot of times, your domain is going to be decided based on these two equations, and then based on that one composition. All right, so now f of x equaling 1 over x, g of x equaling 3x squared minus x. Domain for g of x is all real numbers, it's just quadratic. Your domain for f of x excludes 0. Okay. So now for all of these, you're going to have the intersection between these domain being the new domain, or at least part of the new domain. So for all of these, we are going to still have to restrict 0 because it's restricted in f of x. So for g plus f, 3x squared minus x plus 1 over x, our domain has to restrict 0 stuff. For g minus f, 3x squared minus x minus 1 over x, still we have to restrict 0. For g times f, 3x squared minus x times 1 over x, that becomes 3x minus 1. Domain still has to restrict 0. In this case, we end up with a linear function. Because it came from two other functions, 0 will have a hole there. So you still have a domain restriction. For the next one, g divided by f, g is 3x squared minus x divided by 1 over x. And that's going to flip, and you have 3x cubed minus x squared. Again, even though this looks like just a cubic function, you still have a restriction at 0. There's no new restrictions for this one either. This, when you look at the composite, you can see 0 is the only issue there. and then f going into g, f is the 1 over x, yeah. So 3 1 over x squared minus 1 over x, which is going to be 3 over x squared minus 1 over x. Again, 0 can't be included in this. The domain is still negative infinity to 0 and 0 to infinity. Right. The last thing in this section is the secant line and difference quotient. This is really start of where we start getting into calculus. We're going to start with the difference quotient because we'll do this a lot, and then calculus actually takes it one step further. The idea with this is you have a curve. You see that we have this black line that represents a function f of x. And on this curve, we have 2 points, P and Q, and a secant line goes between those 2 points. And eventually we let Q move in, and you pick a new Q, and then you move in more, and you pick a new Q. And basically along the x-axis, the difference between where P and Q is starts out at H. Eventually, H gets smaller and smaller until we're so close that we're on the p-value. And then that creates once you hit the p-value, you get a tangent line there. And this is the tangent line. The difference of P and Q, well, if we want, we can find that slope of that secant line. So the slope of the secant line is the change in y over the change in x, or change in y is your f at x plus h minus f of x. Change in x is your x plus h minus x. And that simplifies out the denominator. The x's cancel. You have just f of x plus h minus f of x over h. And that's your difference. Okay. So we can work out the difference quotient, simplify the difference quotient for f of x equaling x to the fourth. It's going to be x plus h to the fourth minus x to the fourth over h. And we will have to multiply out this x to the fourth because the idea here is we want to cancel out h at some point, and we're going to have to cancel out the x to the fourth for that to happen. So we have to start out with multiplying this out. So we get x plus h squared times x plus h squared minus x to the fourth over h. X plus h squared is just x squared plus 2xh plus h squared. And that's going to be squared because it happens twice. Minus x to the fourth over h. And then we have to multiply out that x squared plus 2xh plus h squared, FOIL it with itself. So it will become x to the fourth plus 2x to the third h plus x squared h squared. That's multiplying the x squared by all three. And the 2xh has to be multiplied by all three. You have 2x cubed h plus 4x squared h squared plus 2x h cubed. And then the h squared has to be multiplied by everything. So you have x squared h squared plus 2xh cubed plus h to the fourth. And all this minus x to the fourth on that page there. And everything is over h. All right, so we can put all this together. X to the fourth, that's that one. 2x cubed h and 2x cubed h is 4x cubed h. That's this one and this one. X squared h squared, 4x squared h squared, 5x squared h squared. 2x h cubed, 2x h cubed, the 4x h cubed. Now notice I have one more x squared h squared, so that'll make it 6. And then h to the fourth. And then minus that x to the fourth. That's h. And what you should notice here, x to the fourth cancels with that x to the fourth. That allows every one of these terms now that has an h in it to cancel out that h. So you end up with 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And that's your difference quotient. So if you want to simplify the difference quotient for 2x plus 1, we'll have 2x plus h plus 1 minus 2x plus 1 over h. We'll distribute, so we get 2x plus 2h plus 1 minus 2x minus 1 over h. This one's a little easier. Linear ones are always a little bit. The 2x cancels. Your 1 cancels. That cancellation always has to happen. That right side has to cancel. And then you can see you have 2h left for h. Those h's cancel. You get just 2. You again are finding the slope of a secant line. The slope of a linear line is 2. So that makes sense that we get that out. If you think about it, a secant line for a line that's linear, the red one's going to be the secant line. When we go from point here to point here, the secant line will just be the same line, so it has to have the same slope. So it makes sense we would get to. So next one, difference quotient for x squared minus x. Here we have to remember we have to add h to both of these x's. So we have x plus h squared minus x plus h minus x squared minus x all over h. So we'll FOIL out the x plus h squared, distribute the x plus h, the negative sign into the x plus h, distribute the negative sign into the x squared minus x. X squared plus 2xh plus h squared minus x is h minus squared plus x. Now, this x squared will cancel with that x squared. This x cancels with that x. So we're left with 2xh plus h squared minus h. and you have h on the bottom. So the h's divide out, you get 2x plus h minus 1. And then the last thing, simplifying the difference quotient for f of x equaling 2x to the fifth plus 1. Now, we already did, well, I could do it in a minute here. Let me write this out. 2 times x plus h to the fourth times, jumping ahead, the fifth plus 1 minus 2x to the fifth plus 1 for h. Now this is going to multiply out to 2x plus h to the fourth times x plus h plus 1 minus 2x to the fifth plus 1 for h. We did this part, we did the x plus h to the fourth before. We still got to multiply by another x plus h. So let me write out what we had for that. I have to come up to the top here. We had this line here, minus, not counting the minus x to the fourth. So, and I'm going to put it together. Oh, actually, this is x to the fourth. Then we had, that was this one. We had 2x cubed h, 4x cubed h, plus 6x squared h squared. This one, and this one. And then 2x h cubed. And then h to the fourth. And that's going to multiply x plus h. And then we'll plus 1 minus 2x to the fifth plus 1. Again, all this over h. So we'll multiply the x plus h in to all of these, and then we'll be multiplying it by 2. I'm going to try to do that in one step here. So multiply every one of these by x and 2, and then every one of these by h and 2. So 2x to the fifth plus 8x to the fourth h plus 12x cubed h squared plus 8x squared h cubed plus 2x h to the fourth plus, and then we multiply everything by 2 and h. So we'll have 2x to the fourth h. We'll line these up. 8x cubed h squared 12x squared h cubed eight x h to the fourth plus 2h to the fifth. And then all this will be not only divided by h, so we'll be subtracting 2x to the fifth minus 1. 1. Let me put this all together. 2x to the fifth plus 10x to the fourth h plus 20x cubed h squared plus 20x squared h cubed plus 10x h to the fourth plus 2h to the fifth and plus 1 minus 2x to the fifth, all of this over h. Okay, so now we can cancel 2x to the fifth and negative 2x to the fifth and negative 1. The h's cancel h here, one of these here, one here, here. So now, and this one. So now we have remaining 10x to the fourth plus 20x cubed h plus 20x squared h squared 10x h cubed plus 2h to the fourth. All right, and that's the difference quotient for this. Now, what calculus is going to do when we get into it is we're going to let h become 0. That's the whole reason why we need to divide up that h in your denominator, so we can make h 0. And when we do make h 0, every term there becomes 0 except for the first one. That's the easy part. Algebra here is the hardest part. All right, so that's the end of section 1.1. The next video will be on section 1.2, and we'll get into some linear functions and some other functions. See you then. Bye.